Welcome to the Introduction to Programming series. My name is James, and today I'm going to be introducing you to data types, variables, and expressions using the programming language Go. This one is a little bit longer. Feel free to take pauses in between and interact with the video as I leave you slides to ask you questions that you can think about before we moving on. But for now, let's just jump right into it. We're going to recap a little bit. If you haven't seen my last video, I recommend it. Go look for the one that's about programs and statements. It's an introduction to programming languages. But I'm going to recap it really quick on this video in case you've already seen it. And then I'll go through and we'll talk about values, types, expressions, variables, declaration versus definition. See if we can fly through this. Okay, starting with the instruction set recap. We talked about what is programming. We talked about that programming is simply the act of entering instructions for the computer to perform. This means that we can, just like we're talking to a human being, if we want them to do something, some list of things, we give them a list of like, hey, what does it take to do the laundry? Right, separate out the clothes, place the detergent in, place the clothes in, right? We've got this set of instructions that we're giving to a human to then process. Computers are the same way. We use these instructions that are very explicit and specific, and computers don't know broad language. They just have to be spoken to very specifically. But they do know things like we can tell them to remember certain things. We can tell them to add things together. Computers love math. They love doing it for us too. And then display a message, perform some action. We can tell these computers to do things using instructions and statements all we want. In fact, here's an example one in English. Remember that x is equal to 2. And again, I went into this a lot more detail in the last video, but just to show that we can take this English program and we can translate it into Go, which is the language we're going to be using for this series. But we can also translate it into Python, see what it looks like, translate it into C++ and see what it looks like. And these are more, C++ is a bit more of an older language, so it's got it looks a little bit more complicated than some of the newer languages that we're used to. We talked about sequential processing, where sequential processing or sequential computing is the standard method for solving a problem. It just means that when you get a list of instructions, you go step by step. You go one at a time, top to bottom. And here's an example that we talked about. Making a sandwich and ordering a book. You may go to the bakery, you may get bread, you may go to a butcher, you may get meat, make a sandwich, search for a book, and order a book, right? You go in order, you're not getting bread and then jumping to search for a book online. You're going in order one step at a time. And that's what computers do, which is sane, right? Because it's a little crazy to think that we could give it some instructions and it's going to just randomly choose which one it wants. That's frustrating. We talked about instruction sets, which again are just sets of commands that a microprocessor will, it's just a set of commands, a set of instructions that our computers understand. They don't understand free-form language. We can't be too frilly or poetic or artsy with what we say. We got to speak to it very clearly and very succinctly. And it doesn't know a lot of words. It only knows a few, and we've got to put those together to make sentences and instructions and programs that it understands. We talked about it supports math, it supports manipulating words, and also getting input and output from a user. More things, but generally this is what we're going to start with. Sound good? All right. Moving on, let's take a look at values and types. So values, and this is one of the hardest slides for me to talk about because it's so fundamental. It's hard to really describe the fundamentals. But just to say, that a value is one of the most basic things used in computer programming. A value could be a word or a sentence, like hello or greetings, traveler. It could be a number like 1 or 2.2. Heck, it could even be negative 100 and so on. And a value can also be true or false. You'll notice here that we've got, numbers, we've got literally the word true and false, and then we've got these quotes around any sort of free form language you want to talk about. These are values. These are things that a computer can store or things that we can use to interact with our users or get values from our users and interact with ourselves. You'll also hear me talk about this called data, which is why we've got values here, but data types there. You can also consider our next slides as value types. But really, values or data are just things that are what they are, right? The word hello is hello. Hello cannot be anything different. If you see hello with double quotes around it, you know it must be hello. It's like it doesn't impersonate. And that's going to be make more sense when we talk about something else later. But the number one is always a number one. The word false, the idea false is always false. So if we look at this screen, I'll give you about 5 seconds. Feel free to pause in any of these screens to think about it longer. But for now, people who aren't pausing, I'm going to give about 5 seconds to think about this. But what are the values on the screen? Yeah, it's these guys, right? 2, 3, the word Michael, the word Scott. These are values. These are things that stand out as they are what they are. The value 3 is always 3. 3 is never going to be different. We've got some other stuff on here which we're going to figure out what the differences are. But right now, values are just values. Values are just data. They're just what they are. And we can split these into types. In fact, there's a lot of these different data types or value types. But we're going to talk about the 4 basic ones in this language. And these are common across most programming languages. These are the ones you're going to end up using. We'll have integers, which are values that are whole numbers. They can be positive, they can be negative, but they have to be a whole number. You know, negative 362 or 1527. Any whole numbers are integers, we'll call them. Now, if we want to be more precise, we want like a decimal point, we use something called a float. A float it allows you to have what we call precision, but basically it means it doesn't have to be a whole number. So it could be 1.1. Heck, it could be 1.0, but the fact that it allows you to have that 0.0 where you could do more later, 3.14, 33.333. These are all floats because they need that extra decimal point. They have access to it versus an integer just has to be a whole number. You can't split integers and have any non-whole number parts. Strings are then letters, words, or sentences. Anything that has text in it. If you want them to be in a variable, you have to make a string variable. Sorry. If you want to store these things, you'll have to use something called a string. And so you can think of it as a string of letters. You can spaces obviously end in there, question marks in there. So a string of maybe characters, we'll call it. Things that can be, but they're all included in their double quotes. And lastly, true and false, we'll have a type, we'll have a special way of treating these things that can either be only true or only false, and we call those Booleans. So like I warned you, I'll give you some time here, but in the next 5 or so seconds, or feel free to pause, describe for yourself what is a value. Yeah, a value is a value. A value is a data. A value is what it is. A value, for example, is like the numbers 1, 2, or 3, or negative 21.2. Values are literal things. They do not change. They just are what they are. And now here's a cool one. What are the 4 basic data types I just talked about? Yeah, integer was the first one, whole numbers. Floats, which are numbers that don't have to be whole numbers, like 2.0 or 2.5 or 3.1. Negatives as well in there. Strings, which are letters or words or sentences. And then lastly, there was Booleans, right? Or bools. We're going to call them Boolean. Well, they are Booleans. We're going to call them bools, which is just true or false. So bools, strings, floats, and integers. Now let's talk about why we use or how we use values and where we put them. So first we got expressions. Expressions are, I mean, this is fine example, a word or group of words that or symbols that has a value. In programming, expression is a value or anything that executes to become a value. So it's either a value or you can do the thing and it will become a value, whatever the thing is. And if we look on this slide, I'll give you a little bit here. What of these are expressions? Take a guess. Yeah, so the expressions are again values, like two itself, which is a value. It can also be an expression because an expression is either a value or something that turns into a value. So 2 plus 3 is an expression. because it does a thing, right? It takes 2, it adds 3 to it that gives 5, and then 5 is a value. So it becomes a value, therefore it is an expression, because expressions are either values or anything that turns into a value. And furthermore, we'll see down here, you can do stuff with these little guys on the left, use them to do some math or something, and then store that in a, well, we'll see. But we can see this here, Michael and Scott, these are values. The plus sign again tells us it's doing something with these words. And yeah, let's see what these guys on the left are. Variables. So variables are pretty awesome. Everything sort of needs variables. Um, a variable is like a box in a computer's memory where you can store a single value. It really is something like I honestly visualize like a moving box, but it only fits a certain structure. So, but you can put stuff into it, you can take stuff out of it. You can only fit one of a thing. If you're putting an integer in a box and you put another one in, you've got to take the one out or throw it away, right? So variables are how we store information. They are how we get stuff from a user, someone using our program, or a computer itself. And so looking at this screen, I'll give you a second to guess, what are these variables? Yeah, it's everything, these little guys, right? All these things that kind of look like strings that don't have quotes, because strings have to have double quotes around them. Um, but variables are just boxes. These are just boxes that hold things, right? So this is a variable x that gets to hold the value 2. This is a variable y that gets to hold the value 2 plus 3, which is 5. Again, it's an expression that evaluates to 5. So 5 gets to be saved in y. And then the cool thing is we can then reuse these variables just like we do in math or algebra, where we say z is now the value of x times y. Now x is 2, y was 5, so 2 times 5 is 10, so z becomes 10. And so x is still 2, y is still 5, but z is now 10 because we used variables to store numbers, integers, into these locations. And then we use those variables to go say, hey, go to the x box, open it up and take out the 2. Go to the y box, open it up, take out the 5, and let's do something with it. Let's multiply them and get z, which is 10. All right. So maybe you can help me out here. What is an expression in your own words? Yeah, I mean, on the slides, I'll say an expression is either a value or something that becomes a value, but an expression is it really is just, yeah, I don't know how to change it past that. Adding things, subtracting things, these are examples of expressions. Something where you're combining values or data, or just the data, the value itself ends up becoming an expression. And this is one of the coolest things, actually, expressions. It took me a couple of years of programming classes to really appreciate why expressions and understanding what they are is so powerful. Um, but for now, just a basic understanding that anything that is either a value directly or can be combined to become a value is an expression. And that leads us to variables. When do we use variables? Yeah, we use variables when we want to store stuff, right? When we want to access a value later, when we want to do math and save the result, the answer, we use a variable to store it. Now, there's two different ways to make variables, and I want to talk about them here. This small caveat, I think understanding each word isn't the most important as long as you understand how to make the variables. But I do talk to a lot of programmers who use these words on purpose, and so I think it's good for us to cover it. So if you're starting to feel a little tired, maybe take a pause in the video and come to this. But let's talk about declaration versus definition. These are two ways of creating variables. A declaration is to say that something exists. A definition is to say that something is a value. So a declaration is saying like there is a variable that is named X that is an integer. I just said that a variable, I made a box. I am declaring that a box exists. Now, if I wanted to define it, I'd say, hey, there is a variable named Y that is an integer, and it's the value 5. Right? I am defining a variable. I am saying it exists and giving it a value. And here's how it looks like in code. I would say there is a variable, a var, named my name, and it is of type string. So a string again means what? It means that it can be a letter, a word, or a sentence. If you're guessing from my name, it's probably my first name or my whole name, but this is just my name. But you can see here that I use this var with the name of the variable and then the type. I am declaring this variable exists. I haven't decided what to put in it yet. Or I can define it, and I can say that there is a variable named my name. It is of type string. Oops. And the starting value is James. You notice here, if I want it to be the value James, I'm talking about literally the value James. So that's double quotes. I'm saying I want it to actually be the value James versus my variable does not have quotes. So there's a variable I'm calling my name that is a string. And I want to make it the value of James. And then this equal sign is how we're taking the value and placing it into a variable. I almost think of these single equal signs as like an arrow. It says, hey, take that guy, stick him in this box. Let's look at some examples of this. So breaking down, we want to break down how we create a value variable here. Again, we talked about the declaration is three parts. It's these. It is just creating a box. It's creating a variable, and we do this with a keyword, a variable name, and a type. So if I have a number of donuts, that's my variable. I can see it's a variable because it's got var in front of it. This is when I'm creating it. I give it a name. Whatever name I want to give it is fine. I try to be descriptive with my name so I remember what's stored in there. If you have ever moved and you've put on a box that says stuff, right? It's so frustrating to have to open it and go, what was in this again? Oh yeah, it's tough. So you put like a good descriptive name on front of it, on the side of it. Number of donuts. You can guess what's in there. And then I have an integer, an int, which is a whole number. So I'm going to have a variable called number of donuts, which stores whole numbers. It's type int. I can change the name to whatever I want. In this case, now it's miles to run. And maybe I want to have a variable that has a whole number of miles to run in it. Or maybe miles to run, I want to be more specific and I want to use a float. Floats, again, we talked about they don't have to be a whole number like 2.3 or whatever. The float 64 is just the way that we say I want to float in Go. It's a little bit tricky. There's a couple different versions of this, but we're just going to stick to float 64. Don't worry about the others. But variable name, and a type. It's always there. If I want a donut flavor like vanilla or chocolate, that's now a word, which means it's a string. But again, variable name, type. If I want a bool, like is it true or false that I like donuts? I like donuts is probably true or, well, we'll see. But if it's going to be either true or false, then I'm going to put a bool because a bool is when there's only two options that are allowed. And specifically, the options are true and false. But yeah, um, after I've made my variables, my second instruction, my second statement could be to change them, to assign them. We call this an assignment, which again is taking the right side of an equal sign and placing it in the left side. When you create a variable, you have to put this var and you have to say the type, but afterwards you can just use the name later to an equal sign to change it all you want. Maybe miles to run was a float, so I want to use a float value. Both of these work. It doesn't change that I have variable name equal sign value. And putting this all together, we have declaration and an assignment, we get something called a definition, right? That's just the big boy. The big boy is the definition where we're declaring and assigning. Our declaration still has keywords, still has a keyword, variable name, and a type when we are creating it for the first time. And our assignment still has a value. And then we got that equal sign in the middle to make sure that the 15 is going into the number of donuts. Maybe our 3.4 is going into our miles to run, and maybe I didn't have enough room to type vanilla or chocolate here, but you can imagine that I did. I just put double quotes around whatever I type here because it's a value, a string value has double quotes, and it gets to go into the donut flavor. And maybe I like donuts can be true or false. Yeah, and that's what I've got for this lecture. Check for the next video where I'll show you how to create variables and interact with a program in a basic level. Thank you.